So good afternoon, everybody, and welcome to our webinar today, where we're going to take a look at the advanced assembly extension for Creo. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI, and today leading the presentation is Paul Dye, who is an applications engineer and solutions consultant with PTC. So this is a pretty tremendous extension in regards to be able to collaborate better with your fellow engineers, as well as being able to do top-down design and creating skeleton models for a better overall parametric design. And without taking any of Paul's thunder away, I'll just pass everything along to him and he could start his presentation. So Paul, thank you for being on today.
Yeah, absolutely, Rob. And just to confirm, you can see my screen, hear me okay?
Hear you loud and clear. The screen looks good.
All right, awesome. So again, thank you for having me on. For those of you that haven't ever been on with me before, my name is Paul Dye. I am a solutions consultant and application engineer here at PTC, and I'm happy to be on today talking about, in my opinion, probably the strongest extension that we really have in Creo for the majority of people that are working with design. This is something that tons and tons and tons of customers work with right now. People have used to design many of the products that you see out in industry today, and really give you the ability to build into really what we would call top-down design methodology. If you haven't seen into this, I'm going to cover a lot of these different areas within this type of process, exactly how it works in Creo. If you have any questions, feel free to drop those in the chat. We're more than happy to go through and get anything answered for you. But with that, we can go ahead and get started. So before I go through and talk to some of the main capabilities and some of the main things that you're going to work with within this extension, I first like to go through some of the main challenges that we typically see from people working out in the industry around just design in general, especially when it comes to collaboration. We'll go through, speak to our solution with that, with the advanced assembly extension. I might refer to it as AAX throughout the demo as well, just a little bit easier to say. Then we'll go through the capabilities, do a brief demonstration of the tool, and then we'll talk a little bit about how we see moving forward with it. All right, now looking at some of the challenges, especially when you're working with large assemblies, there's oftentimes going to be multiple people or teams working on it, and you need to be able to work together. You need to be able to share information, keep everyone on the same page, and you need to be able to control that process. The last thing you want is two people, working on the same thing, or even worse, working in opposite directions on the same thing. And you see typically as assemblies get larger, they get more complex, you see the losses in productivity become larger and larger as well. And some of the teams that you work with may even be outside of the company, right? It could be partners, suppliers. Oftentimes they need information. You need to make sure that their information is matching up with your information. But at the same time, maybe you don't want to share all of your intellectual property with those outside companies. So you need to have a process to secure it, but still be able to transfer the information that you need to. And really traditionally, CAD is pretty limited that we've seen out in the industry of working with these types of designs, especially when you're working on designs with 10, 15, 20 other people. You really need dedicated tools to assist you with that process. And if you don't have a system in place to work with those larger assemblies, it can be very slow. Be a very tedious process to go through and plan, to document, and ultimately assemble those designs. So whenever it comes to us working or sharing or collaborating around this type of designs, what really can we do? Well, our solution in Creo to address a lot of those problems, and really all of those problems, is with the Advanced Assembly Extension, or AAX. It's an extension that gives you design tools specifically built out to combat the challenges that we typically see when working with larger or complex assemblies. And it really starts here with the idea of top-down design, being able to plan the framework for how an assembly is going to go together, what it's going to look like, and have that all structured and really fundamentally built out from the beginning. It starts with the idea of skeleton models. This might be something that you've heard of or even worked around in the past, but what this really allows you to do is lay the framework for which areas of the assembly that you're going to be working on and give us that foundation to work off of. Also gives you the ability to share and work off of only the areas that you're concerned with. It really helps for making sure that you're not stepping on each other's toes or working in areas that you shouldn't be, or if you have certain areas that you need, that you need to design around, you don't have to bring in the entire model or the entire assembly around that. You can just bring in sort of the skeleton model to build your designs around. Also with this, we have what's called a reference viewer. It's our tool for reviewing and also managing all the different references and the dependencies between the parts, the assemblies, the sub-assemblies. And it's a very visual way of doing this. You have full control over all those references for defining the scope of the model, where each part's connecting together. We really want to manage those references so our models are more flexible over time. And that's really the main goal of top-down design methodology, is the fact that whenever you get further on down the road and you need to make changes, or you need to change certain features or even parts around, you don't have things flash red or give you errors, nothing like that, right? We want you to just be able to make things very flexible and be able to make the changes that you need to, even if it's 90% of the way into a design, you still have the ability to do that. From here, we also have the idea of concurrent design, which is similar, but the idea is now we're going to be working together. So here we might have one designer or engineer that might be in charge of a certain part of the design, right? You have someone that controls the handle, one that controls the blade, one that controls the switch mechanism, even down to the partners or suppliers that manage all the hardware, some of the bolts that go into that, right? And what we have there on the left-hand side is a lead integrator or designer. And what they're doing is using that skeleton geometry and sharing out pieces of the skeleton geometry with each engineer or designer. And they're able to work with it, understand the areas that they need to build within. And then whenever it comes time to something like a design review, and they say, okay, well, what would this look like if we lowered down the curve here? What if we wanted to have 3 indentations for the fingers instead of 2? Well, instead now what they're able to do is just simply update that skeleton model that the lead integrator has been working with, and everyone can update it for that automatically, right? So with that, it's very easy to go through, make those type of design changes at any point throughout that design process. Really allows everyone to work concurrently at the same time. We also have the use of inheritance models. So this is controlling whenever you make changes to certain parts or subassemblies, whether or not those changes get propagated up the line to the parents' parts or the assemblies. We see people use this a lot for having a design model, but then you might want to have an inheritance model for your analysis or one for your manufacturing design. Allows you to work with them, apply shrinkage, or do certain changes that you might need for analysis without affecting the design model. It's a very strong tool that we see a lot of people really getting great use out of as well. We also need to work with assembly configuration. We have tools like interchange groups for things like fastener attachments, or maybe you always happen to go on the same way. Well, you don't have to spend time putting each one in individually, right? So if you have something like a custom electronic fitting, when you're just trying to make it mount, well, with this, all we have to do is pick a face that it goes on, give it a location, and have it all completely set up using those interchange groups. This is also very helpful for swapping out parts for areas that might be designed to order. So that's where you're starting with a standard configuration, but you have 5 particular pieces that could be swapped out, basically dependent on a customer's orders. Right? So you could have one type of switch, one type of fan, one type of CPU board that you can go through and be ready in an instant to get a new configuration based on whatever you need to build out, and then have all the different dependencies and the relationships still tied to that. So basically ready in an instant to go through and get that new configuration based on your customer order. From there, we also want to be able to define the process planning, say how a model goes together. Again, for that, you need graphics, you need bill of materials, you need to do all that for manufacturing to show how this goes together. And we want to be able to define it from our engineering information. So that's something that we're able to do here using our assemblies, right? Is get through all these different configurations, have this assembly process planning built out straight from that engineering information as well. So you can build all that out, have it all tied to the information. And again, fully associative. If you have anything change, it's able to update that as well. And finally here, this really ties in well with our tools for visualization and performance management. Again, if you're working with a big assembly, that can be a huge amount of data that your computer has to crunch. And we can really give you tools to control that. If you only want to look at a particular area, be able to turn certain areas off. For example, if you only wanted to look at certain parts of the shrink wrap, that's going to be able to reduce the time it takes to load up, put it to memory, and be able to work with all that. And even whenever it comes to sharing out, say, a shrink wrap to a certain partner or supplier, it'd be able to do that very easily And even if you have changes to that, you can actually have the shrink wrap be associatively updating for that as well. So that's another particular capability that you have with advanced assembly. And with that, we can go ahead and show a demonstration of this in the context of Creo. I could take a moment here. If we do have any questions currently in the chat, I can go through and maybe provide some insight right now. I don't think we have anything right now, but again, if you have anything that's need any more information, feel free to drop that in there as well. We can touch on that after the demonstration. Okay, and for that, we're going to be working on a train assembly. Obviously, anything remotely approaching the size of a train is going to be a pretty big model. There's lots of pieces, lots of work from start to finish. Even if you break it down to just one particular car locomotive like you see here, it's still a lot of geometry. And advanced assembly is all about managing the model. It's keeping track of when you're working amongst your teams of who's controlling particular geometry, who's working on certain areas. It's really what advanced assembly is all about. And a lot of it revolves around that idea of a skeleton model. Skeleton models can be lines, arcs, curves, surfaces, anything that you need to set the overall control for the model. And the idea is once you have that skeleton model, I can go in here and say, okay, take these surfaces, take these curves, and I'm going to publish them out for particular uses. In this case, it might be for our structural components. And even using that same skeleton model, maybe you want to make another set of published geometry to send to a different designer. This might be someone working on the internal surfaces. So maybe you'll grab one surface or another set of curves. It's really whatever makes sense. Curves, lines, arcs, points, any references that you're going to use downstream. In this case here, we're going to be working on the interior again. So we'll go ahead and take things like the windows or a sketch for that window, and we'll group them in, give them a name so they're easy to make use of later on. All right, so now I've got my skeleton set up and pushed out some of these different components. So again, inside of that structural model, what do I have in here? Well, it might be some that I built out. We'll also go ahead and grab that set of published geometry that I had earlier that I just created. And maybe I'll send that out to a designer that needs to work with it. Right, same thing here for my interior subassembly. I'm going to go ahead and copy the geometry that we had from before. In this case, it's what we call it for interior. So it really got those components sort of fed down from my skeleton models to the particular functions that they need to work around. So it could be multiple different designers. It could be just me organizing my space and working with it from there. And that's part of the key here is I could be working on the structural model. Somebody else could be over working on the interior, and we're not getting in each other's way. And from here, we can go ahead and do a little bit of design work using that published geometry that we sent out. In my note here, I need some additional support hoops to help the structure. I'll just use that curve that we brought down. In this case, I'll just do a sweep to show you how this would work. And we're just going to sweep that section along the curve and build that out to get my beam profile. And really, this is just some standard Creo work, right? Cut out where the upper support structure goes, shell it out to a different shape. It's really whatever you're going to do, right? Just some standard CAD Creo work. And the idea is that the master overall shape is controlled by that top level skeleton geometry. And that's, at the end of the day, what advanced assembly is all about. It's making it very easy to make those connections, to control them. And as we can see here, go through and changing them. If we wanted to pattern that hoop along the length of the cart, we needed to modify the spacing of that, all very easy to do still. And now my support structure looks pretty good here. Got my new hoops, got all that geometry. So what I can do now is go back and turn on all of my structure assembly. You'll see here that with some of these, I'm using lightweight representations. If I don't need to see all the part or just certain parts in particular, we can just turn that off or on and go ahead and move on from there. So maybe in this case, I'm going to work with the interior here. Maybe I need to build something on the wall or work with just a particular piece of this. In this case, I've got the existing wall, and I'm going to go ahead and punch out where that window goes. I need to know what's the size, what's the shape of that window. Well, we'll go ahead and use the geometry that we pulled down from the skeleton to go ahead and create that geometry. In this case, we'll take the loop and make a form feature out of it. We're assuming this is a sheet metal piece that's going to be punched out. We'll give it a little bit of thickness throughout there. In this case, I'm giving it a bit extra because I know I'm going to trim it down based on that surface that we pulled in from the master model. And we're just giving it a taper, rounding off some of the hard edges. And again, it comes out a bit further than we need to. And we're using that curve that we brought in to understand exactly how far out that we want it to go. And copy geometry for that. We're still letting the master geometry control all of it, but I get to use it here inside my work. And I don't have to have the whole train. If I'm just working on the interior, I don't have to load up all that geometry. All right, now my wall's looking pretty good. I have windows, so our passengers can actually see outside of the train. We'll go ahead and turn the other walls back on and regenerate the model here. And we're going to move on from there. We'll go back here to our top level. And if you're working on the top level, maybe you'll set some of the lower levels to a more simpler graphical representation without all of that data being loaded up. And now we can go ahead and start working on the doors. And it's really the same sort of thing. I've got my skeleton model here inside of my door assembly. In this case, I also have a shrink wrap of the rest of the geometry. I need to work on the door and I want to be able to see the rest of the piece, but I don't necessarily need to work with the entire card assembly. And very easy to work around things like that shrink wrap of the model. All right, so now we're going to go ahead and use some of the copy geometry. And one thing that I want to show here that we have the ability to do is changing the update control, right? So typically here, what you have now is the ability to have things automatically update. Whenever you would have a change to anything that's driving this geometry, it could just be automatically pushed down the line and just simply working from there. But one thing that we see a lot of customers and a lot of users of Creo that want to have a little bit more control over that process, have a little bit more manual say over how those changes get propagated down the line, or just having some visibility into that. You have multiple different options. You could set no dependency if you'd like to, or another option that you have here is to set a manual update. In my case, I'll do it with a notification. So later on, if something changes, we'll get a notification of that and we can compare the differences. All right, and we can go ahead and keep moving on from there. We use that surface feature, the surface quote that we copied from the skeleton, and we'll make our door out of it. Similar to before, we'll go ahead and give it some thickness. Maybe we'll also cut out the windows, see how that looks here. And extrude that out. And this is going to be another big drawn sheet metal piece. So we'll first shell it out here. Give that some thickness. And that's starting to look good for the start of my door. Now I could have then the base structure there for my interior of the door. We can turn on the rest of this so you can kind of see where we're going with all of this. And it's starting to look pretty good. Now I've got my door structure. The door is defined using that master skeleton model that's controlling all of this. And we can go ahead and move out here back to our main assembly. So that's again with the advanced assembly, allowing me to set those different levels of representations, allow me to publish and copy geometry to our different functional areas, and still have all the skeleton models controlling everything that we're working with here. And that's really what you need to do a lot of times in order to work with models that are of this complexity. Otherwise, you really have too much in front of you. And now that I have it set up to be controlled here, one thing that I want to do is go ahead and show you what it looks like if we need to go through and make some changes. One of the best ways that we have of doing this here within the context of Creo is using a design exploration session. So this is something that comes just with the base of Creo. It's a very easy to use module that simply says, I'm going to keep track of what you're doing here. And we're making different checkpoints throughout the design. What you're not doing throughout this is creating different save files for all these different parts as you're making new iterations. It's simply just keeping track of it. It's able to go through, show you the full history of the design and not create all those different saves files. So we can go ahead and really just do work as we need to and not make things more complex as necessary. And that's what we're going to do here is just go through and start to make some changes. Maybe we want to pull in the bottom of this, change the material usage. In this case, we'll just bring over that profile and change that skeleton. And what happens whenever we update? Well, essentially everything changes because it was all defined from that skeleton model. And that's exactly what I want in this case. Change everything around those walls. And notice one thing didn't change. And that's actually because earlier we stated that we wanted this one to be a manual change with notification. So here we can go through and see exactly what the changes were with this part. You can see here, if I go into what that update was, we can show the differences, see exactly what the outdated was here. See now what it looks like now that it's been changed. And if I'm happy with it, we can choose to do an update. So it doesn't have to be everything is automatically controlled, everything automatically regenerates. You really can put specific controls there. And using the design exploration, I can add in a checkpoint where I want to reference back to and simply keep working on from there. And that's what we'll do. Keep moving on. So let's go into now our passenger cart. We'll open up a cross section so we can see what we have working inside here. And now I want to go through and make a change. And this really just becomes normal Creo work. Maybe I need to change the armrest, whatever it might be, right? What the design exploration is essentially doing is watching these different changes that I'm making, and it's allowing me to say what I like, what I don't like, and clearly show what happened throughout that in the design history. In this case here, it might be changing the armrest. If I added a feature, reoriented it, it's keeping track of everything here. You can see exactly what the changes that occurred to this model were as well. So the feature that we can work with throughout this at any point in the process. Right, and so these are really helping me to understand where I've been at with the design. Again, if you want to have a spot that you want to reference back to, you can always make a checkpoint at any point throughout the design. And the idea is that you don't have to keep it, right? It's not doing a save as or making new names. At any point, you could say, you know what, that's not where I wanted to go. We can go back over to a different checkpoint, make more changes there. Just do your normal Creo work. In this case, we could try that out here. Maybe we want to go back to a previous point and activate that. So everything's back to the way it was. And that's true of any sort of change that you're going to make. So be able to do that type of iterative design work, but always maintain the full history of the design. All right, so that's what we have now. We have our new shape. We have a new profile for the cart. Again, everything being controlled through the use of our advanced assembly extension. It really gives me the ability to work with these larger and more complex assemblies much more quickly and in much more control. All right, and with that, it's everything I wanted to show in the context of Creo. And before I pass it over to you, Rob, I do want to just make a couple mentions around really exactly why this is valuable. And this is something that you might want to build into your process. And first and foremost, it's really about improving your company's design process, specifically first with reducing time to market, right? If you're able to all work together on your team in a more streamlined product development system, right, you're going to get your products out much faster. You're going to be able to do that type of iterative design work a lot better as well. And the things that you're going to build out are better quality, right? You're not going to have things that get out to the shop floor and you put it together just to realize that it's not going to work, right? Same thing with supplier products that clearly, if you would have been able to share enough information, you could have got things to work, right? So improving that product quality, really start innovating throughout the process, and putting this together, you're starting to develop and define new markets. You're able to, like you saw in the design exploration, you're able to try new things out, try more variations of assemblies that you've already created, and using advanced assembly to really control that entire process. All right, and with that, that's really everything that I wanted to cover today. Any questions again?
Excellent.
More than happy to help with that, but I'll pass it over to you.
Paul, thanks a lot. I appreciate it. Well done as always. One of the things I want to point out to wrap up, hopefully in 30 seconds here, whenever one of our customers is considering an extension like advanced assembly or even Windchill, Creo, whatever it is, we want to show a return on the investment. So if you're thinking, I'm not sure what the return is on the investment for getting something like advanced assembly, we can work with you with that. And the thing that's most important, the question that needs to be asked in regards to getting a return on your investment is how quickly and how proficient and how quick can your people use this tool, becoming proficient at it and using it at a high level. And one of the things that we do for our customers is we provide 2 hours of desk side coaching at a minimum. For every license of Creo that our customer has, we'll give 1 hour of desk side coaching. We give 2 hours minimum so that we could, come alongside your users and help them to utilize extensions like advanced assembly or other areas of Creo to help your team get up and running a lot faster. So with that, that's going to end our webinar, conclude our webinar for today. Paul, thank you again. You did a great job as always, and I appreciate it. And you'll be receiving an email probably tomorrow, most likely tomorrow, to promote our webinar for next Thursday regarding 3D work instructions utilizing Creo Illustrate. So thanks again for being on, everybody, and enjoy the rest of your week.